We're picking up with number 9 on our 4-9 homework assignment, and this is practice problems with orbital notation. And in number 9, we're asked to do the oxide ion. The oxide ion, which is O2 minus. So in order to figure out how to do the oxide ion, we need to first of all determine how many electrons we're going to have to find places for. And they want us to show the electrons. It's 2 minus, and they want us to show the electrons it gained by putting them in a different color so we can see which ones were originals and which ones were gained. Oxygen starts with 8 protons. Therefore, it starts with 8 electrons. If it's 2 minus, it has 2 more electrons than protons because electrons are negative. So if it's 8 starts with 8 positives and starts with 8 negatives, to be 2 minus, it has to have 10 negatives compared to 8 positive protons. So we need to find spots for 10 electrons. It starts with 8. So we'll put 2 on the first level and fill it up. Then we'll begin filling up the second level, which holds 8. The first 2 will go in the 2s. And that will leave me for the original 8, 4 more. 1, 2, 3, 4. That would give me the 8 original electrons. And now I need to put the 2 minus ones in there. So I'm going to add this one, which is the green dotted one, and this one, a green dotted arrow going down. That's the way I decided to designate. Those are the 2 electrons. It started with 4 in the 2p, and when it had 2 added to it, it went up to 6. Why would oxygen want to do that? The answer is 2 plus 6 is 8. It fills that second level. It fills the second level S. The second level P is now full. That satisfies the octet rule. So would oxygen want to be 2 minus? Absolutely. It satisfies the octet rule. Here's oxygen right here. Oxygen would love to become oxide and satisfy the octet rule. 2 minus would give it 10 total electrons. It would be stable chemically like neon. What was oxygen's valence that it started with? Its valence was 6. That's how many valence electrons it started with. Where were the valence electrons? It had 2 in the 2s, and originally it had 4 in the 2p. Remember, this green one and this one green one were added. So that's 3 blues and a red, that's 4. 4 and 2, it started with 6 valence electrons. It picked up 2 more electrons to satisfy the octet rule. Now we're going to take a look at germanium. Germanium, and they want us to do the germanium ion, which is 4 plus. So here we go. How many does germanium start with? If we look on the periodic table, we'll see that germanium starts with 32. 2 go in the 1s, 2 in the 2s, 6 in the 2p, 2 in the 3s, 6 in the 3p. Do we finish filling off the third level? The third level has the D. First level has an S. Second level has an S and a P. Third level has an S, P, and a D. The answer is no. We start filling the 4s first. 2 go in the 4s. Then we can fill the 3D. The 4s has lower energy total than the 3D. So now we fill the 3D, and that leaves us 2 more electrons to be put in the 4p. 2 and 2 and 6 is 10, 12, 18. We start with 2 in here for 20, 10 in here for 30, and 2 in here for a total of 32. But now we need to make it 4 plus. So which ones are we going to remove to make it 4 plus? If it's plus, it's lost electrons. So who do we remove them from? This is very important and one of the most common mistakes. We move them from the valence. So these 2 get removed first. This one and this one. That's why they're in a different color. It asks us to change the color of the ones we removed. So I ghosted them. I should have put them white, but they're ghosted in orange. Those 2 went first. Now, a lot of students will then pull electrons out of the 3D next. No, no, no. The 3D's not the valence. They are removed from the valence. Valence is the biggest numbers first. So they get from the 4p first, the 4s is second. So we're going to remove these two. Why? Look at what it does. The fourth level is now gone. There's no electrons left in the fourth level. So my outermost level now is a 3, not the valence. The valence was the fourth level. It's gone. My outermost level left is a 3. It has 2 in the 3s. It has 6 in the 3p. 2 and 6 is 8. We are left with a octet rule satisfied. It is left with a stable octet. You're like, but what about these in the 3D? Those are not part of the octet. The octet is 8. These 2 and these 6 are 8. These contribute some to stability. It's nice that the 3D is full, but what matters that it's full is whatever S and P are left. So now we would say, does it make sense that germanium would want to be 4 plus and lose those 4? If you look back at our periodic table of ions, take a look at germanium. It loves to become the germanium ion 4 plus. It leaves it with a stable octet. All right, our next question, complete the orbital notation for zirconium 40. Zirconium is atomic number 40. If we look on the periodic table of elements, there it is. If we look for zirconium on the periodic table of elements, here's zirconium right there. It's the second one in this part of the table. It's really the fourth one over after rubidium. So there it is, atomic number 40. We have to find spots for 40 electrons. Here we go. "40 electrons. First we'll fill up the first level, put 2 there. Now we'll begin filling up the second level, which holds 8. First we fill up the 2s with 2 and the 2p with 6. Now we bounce out to the third level. 2 in the 3s, 6 in the 3p. We don't start filling the d though, because Aufbau would tell us to fill the 4s first because it has lower energy than the 3d. So we're going to put 2 there. Now we can fill the 3D, starting with 1 in each orbital. Then we can begin doubling them up, following Hund's rule. 3D is now full, and we can begin filling the 4P next. 4P holds 6, 2, 4, 6. There we are. How many total electrons does that take us up to? So far, it looks like we've found spots for about 36. 2 and 6 is 10, and 2 is 12, and 6 is 18, and 2 is 20, and 10 is 30, and 6 is 36. We need to find spots for 40. So I need to start another level. After the 4P comes the 5S. We're going to put 2 there. And then we go back to the 4D. You're like, why wouldn't the 4D get filled after the 4P? Great question. What's the energy of the 4D? When you're in the D, your second number is 2. 4 plus 2 is 6. When you're in the 5S, there should be an S right there. Why isn't there one? There should be an S right there. In the 5S, the second letter is S. When the letter is S, your energy level or your energy number is a 0. 5 plus 0 is 5. 5 is lower than 6. So we put 2 there. And then our last 2 go into the 4D. And we're done with zirconium. That's kind of interesting. There's 2 in the 4D. Take a look at zirconium. It's the second one over. There's 2. There's a 2. It's the second one over. Very interesting. Very interesting. Now we're asked to answer some questions about this orbital notation right here. Whose orbital notation is this? Oh, that's the first question. Assuming it's a neutral atom, who is this? Couple ways to do this. If it's a neutral atom, the same number of electrons as protons. So let's add up how many electrons it has. 2, 2, 6 is 10, 12, 18, 20, 30, 35. If we look on the periodic table, who's number 35? If we look on the periodic table, number 35 is right here. It's bromine. It's bromine. It's bromine. Next question. How many valence electrons does it have? Well, if we know it's bromine, we now know we could really look on the periodic table of ions and there should be a Roman 7 above it. But valence electrons are electrons in the outermost level. Here's a 4 and here's a 4. My biggest number, my biggest energy level is 4. My valence level is going to be the 4th level. There's 2 here, 5 there. That's a total of 7. So it has 7 valence electrons. Coincidentally, you'll see the Roman 7 above it on the periodic table of ions. Here's bromine right here. Roman 7 above it. Why would bromine want to become the bromide ion and become 1 minus? If it becomes 1 minus, it would have the same number of electrons as krypton. What would that do? Well, we would get 1 electron right here in the 4p. That would fill that p, 4p6. It has 2 in the 4s. If we got one more, it would have 6 in the 4p. 6 and 2 is 8. It would satisfy the octet rule. It would love to be the bromide ion. But that isn't one of the questions. One of the questions is, what are the quantum numbers for that electron going down, pointing down right there? The first quantum number is right there. It is a 2. The second quantum number is given by this sublevel letter. The sublevel letter is a P. When you have a P there, we know the second number is a 1. The third number is the number above this box. ML is our third quantum number. That box number above that is a 0. And which way is this arrow pointing? The arrow is pointing down, so it's a minus half spin. The next one they want us to find are the quantum numbers for this blue arrow pointing up. The first quantum number is right there. That's the energy level number. That is my N. N is my principal quantum number. It should be a 3. My second number is given by what sublevel it is in. It is in the S sublevel. When you're in the S sublevel, your second number is a 0. My third number is the number above the box. It too is a 0 right there. The arrow is pointing up, so it is a plus half spin. What about the next one? What about this one right here? The arrow pointing down. First number is a 3. It is in the D. When I'm in the D, my second number is a 2. D is 2. S is a 0. The P is 1. D is 2. F is 3. So when you're a D, it's a 2. The box number is a minus 2. And the arrow is pointing down, so it's a minus half. What about this electron right here in this box? First number is a 4. I'm in the P, so my second number is a 1. The box number above it is a 1. The arrow is going up, so it's a plus half. The only hard part about doing this is knowing what the second number is. S is 0. If it's a P, it's a 1. If it's a D, it's a 2. If it's an F, it's a 3. Here's a trick for doing it. How do I remember the second number is a D is 2? Because the third number is minus the second number to positive the second number. So if it's minus 2 to positive 2, when I'm in the D, it's a 2. When I'm in the D, it's a 2. Look at these right here. What are the numbers above the box? Minus 1 to positive 1. The number above the box is minus the second number to positive the second number. So if it's minus 1 to positive 1, my second number must be a 1. Same thing here. On this one right here, they wanted to know the quantum number sets. First one was a 3. I'm like, oh my gosh, it's in the S. I don't remember what the second number is. What's the number above the box? It's a 0. There's only one box, so the second number has to be a 0. That's just a trick if you forget what numbers go with the letters. Next video, we'll finish it up.